Alright, so we've got another day, another set of problems. And once again, we are continuing with this theme of like algebra and geometry kind of together. So we're going to be writing some equations of lines, finding slopes, midpoints, all that good stuff, but with past geometry concepts. Alright, so what type of triangle is triangle ABC? Find the equation of a midline of the triangle. So really two parts with this one. So double the fun, so to speak. Well, let's talk about the first part was what type of triangle is triangle ABC? Well, what are my options for a type of triangle? It could be a scalene triangle. It could be an isosceles triangle. And it could be an equilateral triangle. Now, what do each of those, do you guys remember what those mean, what each one has? Well, a scalene has no congruent sides. Isosceles, 2 congruent. And then equilateral, 3 congruent. Wonderful. All right. Well, Jenny just got up from her nap here. She looks to be quite interested on the couch as I'm recording these videos with her on spring break 2K19. Woo! And she's spinning around and I think probably going back to sleep. Yep, she's a little bit bored. All right. Yep, there she is. That's the face of, I'm not impressed, Dad. I already know this stuff. She's already been through geometry, so she knows all this stuff. If you guys need some help, you can just go ahead and ask Jenny. I'm just going to keep Jenny right up here in the, we'll keep it right there. That's a good spot for her. Okay. Anywho, there's Jenny. She knows how to do this, so you can always ask her. All right, so what type of triangle is it? Well, I got to classify this by sides here of scalene, isosceles, or equilateral. Let's do that. Well, how would I do that? I need to find some lengths, right? Because if they're congruent means equal length. When we're talking about like side lengths, right? Same size, same shape. There's another way of talking about congruent when you're talking about like quadrilaterals or any other polygon. But anyways, so I got to figure out my lengths. Well, I know my length of AC. I can just count that, really. That would be 5. I can count that one out. But I can't count out the other ones. That's the thing. I cannot count out the other ones. So there was actually a formula that we wrote down. You should have written down. That is our distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's all under the square root. Okay. So I can use that formula to figure out my length of AB and my length of BC. Right? Well, let's go ahead and do that. So for AB, that would be big old square root. Well, I'm going to write the coordinates on here because I'll make it easier. 1, 2, 3, 4. Oops. -4, comma 4. It looks like a decimal. Let me fix that. Comma 4. B is, looks like 0, 1. And then C, I'll need in a little bit. And that's -4, comma -1. Okay. So for AB, that would be my x2 minus x1. So let's say 0 minus -4 squared plus, and then my y's 1 minus 4 squared. So I'm going to do this by hand because I'm gangster like that. 0 minus -4 is positive 4 squared is 16 plus, and then 1 minus 4 is -3 squared is 9. That is the square root of 25, which equals 5. So boom, this is 5. Okay, so right now I could either be isosceles or equilateral. We finna gonna find out shortly when we figure out this last length. Let's do that. I'll do that in red. So BC. Let's see here. Square root of, well, let's go with, my x is 0 minus -4 squared plus, and then it's 1 minus negative 1 squared. So that's going to be, again, 16 in the square root. And then 1 minus negative 1 is 2 squared is 4. So that's the square root of 20, which if you remember your factor trees would simplify down to 2 root 5. So this guy is, so BC is 2 square root 5. Or you could do a decimal. Let's see, your square root of 20 as a decimal would be about 4.47. Okay? I'm cool with whatever. In algebra, they'll want you to simplify it like 2 root 5. Okay? Lovely. So what does this mean? This means it is isosceles. Very good. All right, now we want to find the equation of the midline of the triangle. Oh my goodness, this is a whole nother ball of wax. You know what, rather than writing a whole equation, because that's going to take a while, a little bit longer than I was planning with how long the first part took, let's just talk about what a midline is. Remember, a midline is parallel to the base of the triangle, or one of the bases of the triangle, and it connects the two midpoints of the other two sides. So that would mean, like, if I wanted to find the midline, let's say I could get my midpoint of AC, which would be right about here, and then I'd want to get my midpoint of AB, let's say, which would be right about here-ish, and then I would connect these two. This would create a midline, right? The mid-segment being just this part, right, that's in the triangle. That is both parallel. They are both parallel to each other, right? And then also the mid-segment is half the length of the base of the triangle. These are all things we could calculate, but again, it would be a little bit longer than I want to spend in this video since we're already at 7 minutes into the video on the first problem. All right? But just a recap of what a midline is. Always good to do that. All right, here it says, explain why the below quadrilateral is a parallelogram. What do you know about the diagonals of a parallelogram? Okay. So a two-parter again. I think we can get through both on this one. So why is it a parallelogram? Well, that goes all the way back to our family tree from Unit 4. Our biggest thing that we know about parallelograms, the opposite sides are parallel. Well, these are definitely parallel. They're both horizontal lines. Could I show that the other two are parallel? Well, yeah. Let's see here. What's my slope? I think we can all figure out what our slope is just by counting, really, with this one. And that's what I'm going to do. We're going to go down 1, 2, 3, 4, 5 over 2. So that's negative 5 over 2. I think a different marker might be more suitable so you can see it better. Negative 5 over 2. And then over here, if I count it out, I'm going to go down 5 and over 2, so negative 5 over 2. Same slope. Boom. These bad boys are also parallel. Cool. So if the opposite sides are parallel, I know it's a parallelogram. That's good enough for me. If it was asking for more specifics, like, could it be any other kind of quadrilateral, you'd have to show me that it wasn't. So, for example, is it a rectangle? Well, no, we don't have right angles, right? We can, one, visually see that because it's on a graph, and two, I could find my slopes of the other ones, which would be 0 because they're horizontal, and that would mean that this guy is not perpendicular to that guy, so I don't have right angles. Can't be a square or rectangle. Could it be a rhombus? Well, I could figure out the length by just counting this one, and then I could use distance formula for this one and show, hey, no, man, they're not congruent, so it can't be a rhombus, so it's got to be a parallelogram. Okay? Now, what do we know about the diagonals of a parallelogram? And when I say diagonals, remember, we mean the guys that cut through the parallelogram, that guy and that guy. Okay? What do I know about them? Well, if you're like me and you've taught geometry for 7 years, therefore you remember all of your properties of a parallelogram from, at the drop of a hat, whatever that phrase means. You know that they bisect each other. Diagonals bisect. Well, what would that mean? That means they split each other in half, right? So this point here, where they split, what would we know about that point? Well, we would know that the midpoint of this guy here right? The middle of this one should be the middle of this one. So could I verify that these diagonals are bisecting each other? I think I got an idea. What if I find the midpoint of this one, right, from here to here? What's the midpoint? And the midpoint from here to here. If they're the same, the diagonals bisect, right? I think that'd be kind of cool to check out because I'm crazy like that and I think this stuff is cool. Maybe one day you will too. You know, maybe you already do. I don't know. Alrighty, so let's find some coordinates. First off, this guy right here is 4, 4. Just counting them out. The next one we've got is 6, -1. And then this one is -3, -1. And then up top here, we're at -5, 4. Okay. So let's see here. I'm going to find the midpoint of the longer one first, right? The visually longer one. Let's do that. So my midpoint would be, let's see here, our x's, so 6 and -5. 6 plus -5 over 2, comma, and then -1 plus 4 over 2. What do I get? I get 1/2, comma, 3/2. I'll just leave it like that. Oop, that's a 4. Let's find the other one. So my other midpoint is, let's see here, my x's, so 4 and -3, 4 plus -3, or just 4 minus 3 over 2, comma, and then 4 and -1 added together over 2. So I'm going to have 1/2. Hold it. The suspense is killing me. 4 and -1 gives me 3 over 2. Oh my goodness, they are the same. Those diagonals meet at each other's midpoints. My goodness, midpoint, bisect, midpoint. Boom, bisect. I remember how they're like, you're like, whoa, what's the difference? Dude, bro, they're both basically the same kind of sort of deal, sort of thing, kind of, in a way, but not really. But, you know, midpoint's a point. Bisect means you're splitting it in half. But if you're saying you're at the midpoint of something, it's kind of splitting it in half. So, yeah, they are very similar terms, but have a slightly different, you know, meaning or situation we'll say them in. But either way, we use midpoint formula. We find that they meet at the same spot. That's pretty awesome. That's exciting to me. Maybe exciting to you. I'm looking over at Jenny right now. Doesn't appear that it's very exciting to her. She's asleep. Again, she already learned this, right? She's already been through geometry. So, anywho, that's cool. Last problem of the video. What type of quadrilateral is pictured below? Justify using algebraic skills and geometric properties. Okay. Quadrilateral quad. How creative of me to name it quad. All right. So we got 4 questions. Is it a parallelogram? Why not? Is it a rectangle? Why not? Is it a rhombus? Why not? Is it a square? Why not? Okay, fun. Thanks, Mr. Allen, for giving us all this extra work. I can just tell you one thing that it is. Well, let's see here. We got ourselves... What can we do here? How about slope? Let's start with slope. Let's find the slope of each one. That's easy to count, right? Especially when it's on a graph. So this one looks like, if I count down, it's -5 over 1, so -5. Opposite over here is also -5 over 1. That's cool. And then if I count out the next one, I am going up to and over 10. So up to over 10, so 2 over 10, that simplifies down to 1/5. If I do that over on the other side, and I count it out, same deal. Okay. So first off, not 1/2. First off, it's, let's see here. Is it a parallelogram? Well, are my opposite sides parallel? They are, right? The opposite slopes are the same. So yeah. Yes, opposite sides parallel, but could be more specific. Is it a rectangle? Well, it could be any of these things now because it is a parallelogram, so yes, but what makes it a rectangle? Right angles, right? Ooh. Linking back to our slope, perpendicular slopes, this guy's 1/5, flip that, negate it, becomes -5. So these two are perpendicular. Woo! These guys are perpendicular. These guys are perpendicular, and same with these. So, do I have 4 right angles? Heck yeah, it's a rectangle. Yes. 4 right angles. Slopes are opposite reciprocals. Therefore, perpendicular. Something like that, right? I'm doing a lot of shorthand here. It's hard to write on this thing. So, but the slopes are opposite reciprocals, so you get perpendicular. And we're talking about like our adjacent sides, or our consecutive sides, if you will. As you work your way around, you get opposite reciprocals. Okay. Is it a rhombus? Why or why not? Well, a rhombus needs 4 congruent sides. If I were to do distance formula or a quick, Pythagorean check, clearly, if I go down 5 and over 1, 5 squared plus 1 squared, what's that going to give me? Let's see here. Let's do a little bit of distance / Pythagorean. If you guys ever noticed that, you may have. If I create a right triangle here, I'm finding my hypotenuse of that right triangle. If this is 5 and this is 1, 5 squared plus 1 squared is equal to c squared. Yeah. So that's 25 plus 1 is 26. 26 equals c squared. So square root of 26. All right. You may like that better than distance formula. The distance formula is going to give you the same results. If it's on a graph, you know what? I'm just going to make a right triangle if I can do that. All right, let's do the next side. Let's see here. Let's see if this would be up to over 10. I've created this right triangle. I want to find my hypotenuse. What's 2 squared plus 10 squared equals c squared. So 400, 104 equals c squared. Well, when I square root that, square root of 104, is that the same as square root of 26? Heck no. No. All sides, that is a terrible, there we go, sides, all sides not congruent. So, popping down to, is it a square? No. C above. I mean, it's got the 4 right angles, right? But all sides are congruent. No way it can be a square. So, most specific name would be a rectangle. But it is also a parallelogram. That is the truth. It is also a parallelogram, but more specifically, a rectangle. All right, awesome job. You guys know that some of these videos got a little long, but you can handle it because you guys are awesome. America, freedom, rock and roll. Jenny's back to snoozing. Good stuff.